Understanding recursion in Python. A beginner's tutorial. Recursion is a programming technique where a function calls itself to solve smaller instances of the same problem. It can be a powerful tool for solving problems that can be broken down into smaller, similar subproblems. Key concepts of recursion. 1. Base case. This is the condition under which the recursive function will stop calling itself. Without a base case, the function would call itself indefinitely, leading to a stack overflow. Recursive case. This is the part of the function where the function calls itself with a modified argument moving closer to the base case. How recursion works. When a recursive function is called, a new instance of that function is created with its own parameters and local variables. This stack of function calls continues until the base case is reached, at which point the function returns a value back through the stack of calls, unwinding and eventually returning to the original caller. A simple example: factorial calculation. The factorial of a number and denoted as in. The mathematical definition can be defined recursively as follows: base case 0. Here's how you can implement this in Python. Python def factorial and base case. If 0, return 1. Recursive case else return factorial 1. Testing the function. Print factorial 5 output 120. Print factorial 0 output 1. Example 2. Fibonacci sequence. The Fibonacci sequence is another classic example of recursion. The sequence is defined as follows: base cases fib 0, 0, fib on 1, recursive case fib and 1, fib and 2. Here's how you can implement this in Python. Python def Fibonacci base cases. If 0, return 0, elif on return 1, recursive case else return Fibonacci 1, Fibonacci 2. Testing the function. Print Fibonacci 6 output 8. Print Fibonacci 10 output 55. Example 3. Sum of a list. You can also use recursion to calculate the sum of a list of numbers. Here's how you might implement it. Python def sum list else base case. If the list is empty, if len else 0, return 0, recursive case. Add the first element to the sum of the rest of the list, else return else 0, sum list else. When testing the function numbers 1, 2, 3, 4, 5. Print some list numbers output 15. When to use recursion. Recursion is particularly useful when the problem can naturally be divided into smaller subproblems. You will be working with data structures that are inherently recursive, like trees and graphs. You want a clean and concise solution, even if it may not be the most efficient in terms of space and time. Caveats. 1. Performance. Recursive solutions can lead to higher time complexity and can consume more stack space compared to their iterative counterparts. For example, the Fibonacci example above can be optimized using memoization or iterative methods. Stack overflow. If the recursion is too deep, i.e., too many recursive calls, it can lead to a stack overflow. Python limits the recursion depth to prevent this, which you can check using import sys print sys get recursion limit. Conclusion. Recursion is a powerful technique that can simplify complex problems. Understanding how to identify base and recursive cases is key to effectively using recursion in your programs. As you practice, you will find that many problems can be elegantly solved with recursive functions. Remember to consider the trade-offs in performance and stack depth when deciding whether to use recursion in your solutions. Happy coding!